Good morning, everybody. Welcome to Advanced Windows Troubleshooting with Sysinternals tools. My name is Mark Russinovich. I just want to get an idea of how many people have been to Sysinternals. So if I could see a raise of hands. Now, how many people have never been to Sysinternals? So you're excused. I'm just kidding. How many people have never used Process Explorer before? And I'm assuming that all the people that have not been to Sysinternals have not used it, although I don't see all of their hands going up. So I'm going to go ahead and just skip my background. You can go to the Sysinternals website to learn about that. And go right straight to the agenda of what this presentation is going to cover. Well, I'm going to start out just by talking about Task Manager, and that's going to be a nice lead-in to Process Explorer and why I developed Process Explorer and the things that Process Explorer shows you that Task Manager doesn't. And then what I've done is broken down the functionality of Process Explorer into various categories. And what I'm going to do as we go along here is take you on a whirlwind tour of all the things that Process Explorer can show you. I'm throwing a lot into an hour and 15 minutes. And along the way, I'm going to try to talk about how you can leverage the stuff that you're seeing in Process Explorer to troubleshoot real-world problems. So the first thing we're going to look at after Task Manager is focus on the process view in Process Explorer. And then I'm going to spend a chunk of time talking about accounting for CPU usage, which is the process of figuring out what's consuming my CPU exactly. And there's certain scenarios where there's really no good Windows tools that will help you identify exactly what it is that's hogging your CPU. And Process Explorer can delve in deep into a process and show you that kind of stuff. And then I'm going to talk about the handle view and the DLL view, which you'll see are alternate views of information in Process Explorer, and wrap up with the system information view. So let's start talking about Task Manager. And I want you to start with a little thought experiment, kind of let your imaginations go and pretend that your Windows system is running slowly. I know that doesn't really happen very often, but let's just pretend that it's happened. And the first thing that you might be inclined to do is to run Task Manager and to see what's going on. And if you pull up Task Manager, you get taken to this tab right here, which is called the Applications tab. That's the default view in Task Manager. And it shows you a number of apps that are running on my system, and it says that they're running. But that doesn't really tell me what's making my system run slowly. So what you're probably do next is to go to the Process tab, and that will show you the processes that are running on your system and that are consuming CPU. And there's this nice CPU column here, which you'll typically sort by to see what's hogging your CPU. And let me go ahead and create something that's going to start using CPU for me so we can actually see this. So I've got something using CPU, and it's called CPU Stress right here. It's a Windows 2000 Resource Kit tool that's sole purpose in life is to hog your CPU. So we've sorted by CPU. Now we have identified the process image, so CPU stress.exe. Well, and that might be enough of an answer. I'll come back to what we do with that kind of information. But first, I'm just going to give you a little bit of background on what a process and a thread is, because a lot of what we're going to cover today focuses on what threads are doing within a process. So let's get the distinction between the two out of the way. A process is essentially a container. Associated with a process, you've got an address space where an application's data and code are typically mapped in so that it can be executed and read. It includes a set of handles to resources that the process has opened. And whenever a process wants to interact with something on the system, like a file or a registry key or a piece of shared memory, it's going to open that resource and it gets back something called a handle. And then when it wants to perform further interaction with that resource, it just simply references that handle, which corresponds to the resource that it opened. So the handle table is associated with the process. All of the threads in the process share that handle table. So all those handles are visible to all those threads. And finally, there's something called a security profile, or a token, that's associated with every process that identifies who it is that owns this process, as well as what kind of security capabilities they've got. And we're going to take a look at that as we go along. So then what's a thread? Every process has at least one thread, and a thread is execution context within the process. It's what actually goes and execute code. So I'm going to be saying just in shorthand, the process executes this, the process does that. What I really should be saying, to be really correct about it, is a thread executes this, a thread does that, because processes don't do anything. The threads within the process are what do things. It's also the unit of scheduling on Windows. So when the scheduler is trying to figure out what process is going to get the CPU, it really doesn't look at processes. It looks at the threads that are running on the system, and it'll pick the thread with the highest priority, typically, and schedule that to consume CPU time. And then the thread will either voluntarily give up the CPU, or the scheduler will decide it's had enough time on the CPU and put another one on it and take that one off. So all threads, because they share a process, share those things that are associated with the process, including the address space and the handle table. Like I said, they all share the security profile of the process as well. So then if we've got the definition of processes and threads out of the way, when we pulled up Task Manager and it took us to this tab, what exactly is an application? Well, in fact, really in the Windows internals, the Windows OS has no concept of an application. And you'll also see task as a term used here on this dialog, and the Windows OS has no concept of a task either. These are made up names for Task Manager. So what is this list then? It's actually a list of some of the visible windows on the current desktop. So top-level visible windows that satisfy a certain number of criteria defined by their style bits in the Windows object for that process cause it to show up in Task Manager's list here. And you can see that this is a subset of the windows on the visible desktop because there's some that are missing. So it's not even a complete list of visible windows. And the ones that are missing, for instance, are the desktop itself, which is a window, and it's not showing. But there's another one that's very obvious that's not in this list, and that's the one that's showing you this list, and that's Task Manager. And my theory is that Task Manager is too embarrassed to put itself in this list. So then, now that we've established what exactly this list is, and we've established that threads are what run, how can a window run? Well, my windows don't run unless I move it around the screen. That's kind of running, but they don't actually run. So what does this running term mean? Running actually means that the thread that owns that window is waiting for a Windows message. So it's ready to respond to input, or for me to do something like move this window around or click on a button or something. What's the other state that you'll see here? It's not responding. And not responding means that the thread that owns that window has gone off and is doing something else, and it's not waiting for a Windows message. It could actually be off doing something useful work, doing some processing. But Windows will show it as not responding when it's actually off running. And the threads that are actually sitting there waiting are shown as running. So it's a little bit of a backwards notation here just to show you how kind of misleading this dialog is. And so that's why I'm not going to refer to it again. And when we look at Process Explorer, you're going to see that I don't even have this kind of tab on it. So let's go back and look at identifying the image. When I pulled up Task Manager and identified what was consuming my CPU, it was CPU stress.exe. And sometimes I might know what that exe is. I just ran CPU stress, so I know what it is. But what if it just shows up on my system one day? Or what if some other process shows up with a bizarre image name that I don't have any clue what it's all about? Well, Task Manager doesn't really show me anything else about that image to help me identify it. So how do we figure out what that image is that's consuming our CPU time? What we need is a more powerful tool. What we need is Super Task Manager, Process Explorer. So Process Explorer is a free tool that you can download from Sysinternals.com. It runs on Windows 95 through Windows Millennium. It runs on NT4 through Server 2003. And I've recently ported it to the x64 architecture, Windows 64-bit, running on the x64 architecture. So let's take a look now at the things that Process Explorer shows you that help you identify the purpose of an image. And if we put this side by side with Task Manager, you can immediately see some obvious differences between the Process View in Task Manager and the Process View in Process Explorer. One of the most obvious things is this kind of indenting that you've got going on over here on the left. The indenting reflects the process tree when the system boots up and processes start being born, they create other processes. And there's a parent-child relationship that's happening there. And what Process Explorer shows you in this tree is that parent-child relationship. So you can see, for instance, that WinLogon, because it's indented and directly beneath smss.exe, is a child of that process. And sometimes that alone can be useful for understanding the purpose of a process. Here's the Service Control Manager on Windows. This is the process that's responsible for managing the Win32 services that are running. And every direct child of services.exe is going to be a service hosting process. Some other very visible differences include the process icon, which in some cases can be a visual cue as to the purpose of a process. So you can see down here PowerPoint has the familiar PowerPoint icon to it. And then if you look at the columns that we see here, we've got the process ID column and the CPU column like we see in Task Manager, and we also have some additional columns that show up here, a description column and a company name column. The description column and the company name column are pieces of information that Process Explorer extracts from the image itself. So if you're ISV, you want to be friendly and help people understand what your process or your image is all about. And so what you do is you embed some information in the resources of that image that help identify it, and that includes a description. So, for example, if we looked at command.exe, it says Windows Command Processor, and it's from Microsoft Corporation. Just to give you to show you how this alone can be useful is if we look through this list, we can find processes like this one right here, and RD, wait, let me see if I can freeze this. So it's rpdflchr.exe. So what is that? Let's go to Process Explorer and see if we get any information about that image. And here it is right here. Let me move this out of the way. And it's the Robo PDF application launcher from Macromedia. So there's a cryptic image name that's revealed with the description and the company name. Another thing that you get, and you might have seen this as I was moving the mouse around, is if I move the tooltip over a process here on the left side, I get the path to the image on disk. And that sometimes also can be a cue to what the purpose of that process is. I've got a process here on this system, let me see if I can find it right here, that has no description and no company name. So this is a vendor that's really not being very friendly because it makes it very difficult to understand what the purpose of this image is. Its name is dsrsvc.exe. That's also not very useful. But if I move the mouse over this and look at where this image is located on disk, it's in Program Files, CompuWare, SoftIce, Driver Suite, Common, Bin, DSR service.exe. So this tells me it's part of the SoftIce debugger, which I've got installed on the system. Now, if you don't like the tree view in Process Explorer, you can simply sort by whatever column you want. Here we get it out of tree view. And if you want the tree view back, it's a three-way toggle, or you can use the tree view button up here to get that tree view back. Now, one of the things that I also wanted to emphasize as I developed Process Explorer is to make it easy to see what's changing on your system. And when you run Task Manager, for example, it's really hard to see, if you don't have this thing sorted by CPU, what's consuming CPU, because it's hard to separate out those 0 zeros from maybe a 01 or a 02 or 03. So in Process Explorer, you might have noticed that over here in the CPU column, all the entries are blank except for ones that are non-zero. So that helps me very easily see, look, system idle process, services.exe is consuming 1%, down here CPU stress. A lot easier to really zoom in quickly on what's consuming CPU. The other thing that we can see in Process Explorer is that will help us see what's happening on our system as it's happening is something that I call refresh highlighting or difference highlighting. And you'll see as we go along here today that I've applied refresh highlighting or difference highlighting to virtually everything that you see in Process Explorer where something can change. And the first place that I'm going to show you that is in the process view itself. So the first thing I'm going to do to emphasize the refresh highlighting is to pause the display. And I can do that in one of two ways. I can go to the View Update Speed and select Paused, or you can see that I can use the spacebar key to pause the display. So I'm going to show you the spacebar key there. I've now paused the Process Explorer's display. And I'm going to launch a new process. Let's launch Notepad. And I'm going to go back to Process Explorer and press F5 to refresh. And there, showing up in green, is the new process. And so if I was just actually letting this run and new stuff was showing up, they would show up in green. And I can also control how long that green shows up by going to this difference highlight duration. By default, it's going to be 1 second. If I've got it in manual refresh mode, it's going to stay there until I do a refresh again, that highlighting. And I've just refreshed again, and now that's gone. Similarly, for things that exit or are deleted, they'll show up in red for that period of that amount of duration. So that will show me those kind of changes as well. So let me go ahead and put this back now. Now what I'm showing you is I brought up Process Explorer in its default view. So what you see the default columns that are available, but there's a slew of columns that you can optionally add if you're interested in seeing certain types of information about a process very easily right there in that front display. And I'm going to just demonstrate that by adding one particular column that might be useful. And I do that by going to View, Select Columns, or just by right-clicking on the taskbar here. And you can see that there's several tabs of different types of columns that I'm going to select. This first, right now I'm going to focus on this Process Image column, column selection page, which lets me select columns that are kind of static information, not really performance-related information. So here's the description and company name columns, which were added by default when I ran. The window title, the session ID if you're in a terminal service system, the image path you can have as a column, the command line, and something called the comment, which I'll talk about later. So what I'm going to do to demonstrate this column addition is to add the username column. And that column now appears over here on the right side. I'm going to move it over here so we can see it more clearly. And if we compare what we see here in the username column Process Explorer with Task Manager, there's a difference, and that is that in Process Explorer, I'm showing you the issuing security authority of the account, whereas Task Manager just shows you the account. And this sometimes can be useful in situations where you've got a local account that has the same name as an administrator account on a domain, or sorry, as a domain account. And that would typically apply to the admin account. So if you've got processes on your system that are running in the local administrator account and other processes that are running in the domain admin account, in Task Manager they're indistinguishable by that in the username column. But here you'll see one will have the local computer name as the security authority, and the other one will have the domain name as the security authority. Another thing you can do, if just like in Task Manager, if you're only interested in processes that belong to you, is to go to View and uncheck Show Processes from All Users. And by the way, you'll notice that all of these show up in blue. And why are they in blue? Let me just briefly talk about the color coding that you see here. The blue processes are the ones that are owned by the same user account that was used to start Process Explorer. The white processes have no special characteristics. They're running in some other account. And they're differentiated from these pink processes because the pink ones are running Win32 services. And I'm going to focus on that in a few slides. And there's some other color codings that you'll also see as we go along here. So let's delve a little bit deeper into process. We want to get some more information, and we can get a whole bunch more information by looking at the properties of a particular process we're interested in. You can see the properties just by double-clicking. I'm going to double-click on PowerPoint. And let's talk about what we see here on this first page of the process properties. We see information about the image, some of the information that we saw in those columns, like the vendor name and the description. We also see the version number, and we see the time right there that the application was linked. So this version of PowerPoint was compiled at Microsoft on July 30th of 2003. We see the path to the image, and we also see the command line that was used to start this image. I'm going to come back to that in a second. We also see the current directory of the image. So this current directory is used by the process when it's loading DLLs and opening files and not specifying the explicit path to those DLLs or files, because file searching starts in the current directory, and so that can affect the behavior of the process. You'll also see the name of the parent, the user account name that's running this process, the time that it started, and this can be useful if you've got something that shows up on your system that seems suspicious. You might want to look at when it started. If it started at the same time that all of the system processes, which are the ones that you see basically up here in the top part of the display, started, then you'll know that it started during the boot process at some point, so something automatically launched it. If you see it started in the middle of the night, well, it's time to start figuring out what happened in the middle of the night to cause this thing to get created. And here's the comment field. This you saw when I pulled up the column selection dialog. There was a comment checkbox to add a comment column. And I added this because of user feedback. A lot of people want to, on their server systems, to have a good idea of what processes are running. And it's not easy to always remember the purpose of every process. And so what you do with this is to add a description like, this is a test, and then add the comment column, and if they see a process show up without a comment in it, well, that's something new, something that should be investigated. And there's a few ways to see it. There's another way to see the comment besides just adding the comment column or looking at this, and that's if you've got a process with a column, with a comment, and you do the mouse hover over it, there you see the comment there in the tooltip. This is a test. So I told you I was going to come back to the command line and show you how that can be useful for troubleshooting things. There's a number of situations where you launch something that's a host process for something else. And so you might see in the image list or the process list this host process, but not have any idea of what it's actually hosting. And the command line then can reveal that information. And I'll just show you a very simple example. And that's this time date applet right here, which is a control panel applet. Control panel applets are hosted by a process called run32.dll. Sorry, run32.exe. So if I go back here and I find that run.dll32.exe, this is, I know that this is the host for that control panel applet. If I'd had been watching in Process Explorer and I double-clicked on that applet, I would have seen this show up in green telling me that this is the process hosting that thing. So what if I see one of these? What is it hosting? I look at the command line, and I see right here, timedate.cpl. So that's how this thing was launched. So incidentally, this is the magical syntax to launch a control panel applet. Let's take a look at some more of the pages. The next page on the process properties dialog is the performance page. And here you get a bunch of information about the performance characteristics, performance-related statistics for the process. That'll include the priority of the process, how much CPU time it's consumed, up here in the top left, the various memory statistics associated with the process. And I'll just spend a second here talking about how bogus the memory statistics you see in Task Manager are. If you rely on Task Manager to try to detect a memory hog, and you look at the default memory-related column that it displays for you, you're going to be misled. And the reason is that this mem usage column isn't showing you the amount of virtual memory consumed by these processes. It's showing you the amount of physical memory assigned to the process. And if you've got a virtual memory, if you've got a memory leak in a process, the way that that's going to affect the system is by leaking virtual memory. It's not, and it's going to consume physical memory up to a point. The system will keep giving it physical memory to back that virtual memory until it's decided, hey, I've given this guy enough physical memory. And from that point on, the guy continues to leak virtual memory, but it's leaking in the paging file, not in physical memory. So the mem usage column will grow to a point and then stop. What you really need to look at for a memory leaker, in Task Manager, it would be virtual memory size. In Process Explorer, it's a more accurate description of what's going on, and that's private bytes right here. So this is the amount of private virtual memory, non-shared virtual memory consumed by this process, and that's the number that you should be looking at if you're looking for a memory leaker. And you can, of course, add any of these statistics as a column. If we pull up the Select Columns dialog, you can see that all of these are selectable here. So this is what I'd want to add. if I was looking for a memory leaker, and I'd track that, how it changes. We've got the handles up here. These are the operating system resource handles that I talked about earlier. These are Win32 object handles. These are window objects, and there's a limit on the number that are available on any particular desktop, 10,000 by default of each of these. And if you've got somebody that's leaking one of these, you'll get weird display effects, like bitmaps that don't show up and things that don't redraw right and so on. And then you've got I/O-related statistics down here. And this is the same kind of stuff that you'll see in perfmon. Now, one of the things that I decided that I thought would be useful when you're trying to track a process's performance is to look at its CPU usage over time, something that you don't get when you look at just this display of what it's doing right now. I want to see a history of how it's consumed memory and maybe how it's consumed CPU. And you can get that in the next page of that process properties dialog I'm going to show you right here, the performance graph column. This is like Task Manager's system information view, but this is focused only on this particular process, in this case CPU stress. So you can see I've had CPU stress consuming CPU. It's the system's giving it variable amounts over time, so that's why you see the rough edges there. And you can see how much memory it's consumed as well over time, and it's been pretty flat. And one of the things that I thought was lacking in Task Manager's view of memory and CPU usage history was that you didn't know when a particular, if you saw a spike, for example, you didn't know when that spike took place. And so what I've done is, if you move the mouse over the display, you'll see, in this case on the upper right, the time that particular CPU usage was recorded. And the same thing applies down here in the memory display. The next column, the next page I'm going to show you is the security page. So we'll just take a look at the security page for CPU stress. This is showing me basically inside the token associated with this process. This is the information that the system uses to identify who this is. And the top panel here in this page is the group membership that's in that token. This really reflects the group membership of the account that this process was launched in at the time that that process was created, or at the time the user logged into that account. And the bottom half of this display shows you the list of security capabilities, or privileges, they're called on Windows NT, that are assigned to the various groups in this account at the time that the user logged in. And you can see that some of these include backup privilege, the create a page file privilege, the debug privilege, and other privileges. I'm running in an admin account. That's why I've got all these privileges. The reason that you see some of them grayed and some of them clear are that the security model in Windows NT dictates that a process that has a privilege can't exercise the privilege unless it enables it. And that's supposedly to prevent a process from accidentally using a privilege that it has. So because the shutdown privilege is disabled here, this process, if it tried to call the shutdown API, would get an access denied. First it has to enable that privilege, and then it would be able to call the shutdown API. And the clear ones, without any flags here, the ones that are shown in white, those are enabled privileges. One thing that I think is useful about this in a domain environment, there's domain environments that are very complex in terms of group membership. You've got local groups, you've got domain global groups, you've got nested groups. And a particular user can belong to lots of different groups. What I like doing, showing is when we're at Microsoft and I'm showing Process Explorers to have people bring this up on their own accounts, and they'll oftentimes find that they're members of groups they didn't have any idea even existed. So this is really a resultant set of groups page and a resultant set of privileges page. This will show you for any particular account the authoritative list of what groups they belong to through nesting and whatever other means there are. Now I'm going to show you a demo of a privilege getting enabled. You'll notice that in this process, the system time privilege is not enabled. Let me see if I've got my clock applet here. The clock applet is obviously going to be wanting to change the system time if I direct it to. And so if I bring up the properties on it and look at its system time privilege, you'll see that it's enabled it in preparation for me changing the time. Now, how many people are working with .NET in their environment? Can I see you raise your hands? So quite a few people. And I've added some capabilities into Process Explorer actually at the request of a guy on the .NET runtime team at Microsoft. And if you're running in a .NET environment, this might be useful for you, or you're doing .NET development. And what I'm going to do is launch a process here that's a .NET process. And we see that process, you'll see that .NET by default is processes are highlighted in yellow. So this notify alert.exe process is a .NET process. And when you look at the process properties for a .NET process, you'll have this .NET column over here. The .NET column will show you the application domains or the app domains that are registered in that process. And again, this is dynamically updated. So if app domains are coming and going, you'll see those with refresh highlighting and so on. And also down at the bottom, what Process Explorer shows you is all the .NET related performance counters that are available on the system. And one of the easy ways to scroll through this is just with the left and right arrows. And you can see, for instance, .NET memory statistics for this particular process. I've also made it so that for .NET processes, if you want to see that kind of information, you're doing heavy .NET development, you can add .NET related columns over here. So let's look at app domains. And you can see that there's only one process on the system that has any app domains in it, and that's that .NET process that I've just added. And again, that's all updated in real time. And incidentally, the process that I showed you, this is from Dell. You can see that this is in the program files Dell support directory. Dell is actually, this is a Dell laptop I bought a few months ago, and it came with this .NET app that brings down Dell alerts onto my laptop. Another tab that will only show up for certain processes is the Service tab. So I told you that all the processes in that list that are highlighted in pink are running Win32 services. What services are they running? That might be another question that we've got, because some service processes can host more than one service. And we'll take a look at that tab in a second, but I'll show you the alternate way to see what services are running in a process, and that's with the task list or T-list commands that come with Windows or that are available with Windows from Microsoft. And if we run task list /service, this will show us over here in the services column the services that are running within a process. If you take a look at this service host right here, you can see it's running a whole bunch of services. Unfortunately, what it shows us as the name of the service is just the service name. And in a lot of cases, the service name is not very descriptive. There's services in here that have very kind of cryptic names. Well, here's the crypt service, and I guess that has a cryptic name. But the sense service, for example, has a cryptic name. How can we get more information about what those services are? Well, like you've probably guessed, it's the Services tab in Process Explorer. So I'm going to open that same service host, which is Process 1228 right here, and go to the Services tab. And here's all the services running there. You see the service name. You also see the display name. And the display name is sometimes more descriptive. So that Sense service, well, it's the System Event Notification service. But you also see when you select on one of these, down here in the bottom, is the description of the service. So that, what does that do? It tracks system events such as Windows Logon, Network, and Power Events, notifies COM+ event system subscribers of these events. All of this information, by the way, is stored in the registry, and it's directly accessible through the Service Control Manager API. So it's up to the person that wrote the service to provide this additional level of information. Process Explorer simply displays it for you. We're going to come back to looking at services when we talk about CPU counting, because that's a good example of how to troubleshoot these things. Now, I'm really kind of pleased to launch here Process Explorer 8.4, which is what I've been showing you. The current version on Sysinternals is Process Explorer 8.35. Process Explorer 8.4 has a number of enhancements. One is flicker-free updating of the display, which when a process comes and goes, if on previous versions of Process Explorer, you would see a kind of a redraw of the whole display, which I thought was annoying. So I got rid of that. But the other big feature that I added is this tab right here on the process properties, the TCP/IP endpoints tab. And I also had several requests for this from users. What this shows you are the active TCP and UDP endpoints that a process has. I'm going to pick a process that I know has some open, or at least that I can create some for. Actually, that's the wrong one. So this is my browser. Let me go to a particular site, like, let's just go to Microsoft.com. And go back to, do I have this paused? No. Okay, here we go. And we see the same, those endpoints opening up and closing in real time again. And we've got this resolve address button down here, so if we want to see the actual IP addresses associated with resolved names, we can see them, as well as the state. Now this, if you're familiar with Sysinternals tools, you might be familiar with another tool, which I'll just briefly mention, and that is TCP View. TCP View shows you the endpoints that are currently active for all the processes on the system. So that I've taken that functionality and put it in this tab, which just shows you the endpoints associated with a particular process that you're interested in. So there, we've resolved that name to origin2.microsoft.com. Now, I'm sure that there's been times for you, like there's been for me, where my system is in the middle of doing something CPU intensive or disk intensive, and I want to or network intensive, and I temporarily want to stop it from doing what it's doing so that I can accomplish something else. Like, I want to go download a patch to my game or play my game while I'm doing a service pack download. I want to stop that service pack download temporarily and then play my game for a few minutes and then resume it. Not too much to ask for, is it? But if I kill the download of service pack, I've got to start over from scratch. And what if it's already downloaded a few hundred megabytes? So there's no built-in tools in Windows that let you say, hey, just freeze this guy where he is, and then I'll continue him later. So what I've added in Process Explorer is an ability to suspend a process. And I'll demonstrate that by suspending PowerPoint itself. We'll see how it behaves. And the way that I can suspend is by right-clicking and saying suspend. And suspended processes show up in this dark gray color. Now, the interesting thing about this is that you still see the PowerPoint slide there on the display, but PowerPoint's no longer really there. It's asleep. And that kind of makes it a bitmap drawing program, which I think is kind of fun. Now, incidentally, what do you think Task Manager is going to say about PowerPoint on its Applications tab? Anybody want to take a guess? Not responding? I've heard some people say not responding. Let's go look. It's running. Why does Task Manager say it's running? Well, because it went to sleep waiting for a Windows message. So it's actually satisfied the Task Manager criteria for something that is running and responding, and that is it's waiting for a Windows message. It's just asleep waiting for a Windows message. So I've sent it a whole bunch of Windows messages that it just is not catching because it's ignoring them. But Task Manager tells us a different story, and that's why I just wanted to highlight the total bugosity of this tab and why I don't show it. So let's go ahead and resume, and now we're back. Okay, let's move on to accounting for CPU usage. One of the things you'll see when you run Task Manager, it's very evident that it's rounding CPU usage to the nearest whole number. And that's hiding a lot of stuff, it turns out. One of the things you can do in Process Explorer to get a little more accurate view of CPU usage is to go to the View menu and select Show Fractional CPU. And now what that does is stops the rounding, or at least takes the rounding to do 2 decimal digits here. And that shows you a little bit more accurately and shows you things that will be under the radar. If they're less than 1.0, Task Manager won't show you, but Process Explorer will with this fractional CPU usage on. But even then, things can slip in under the radar and execute without the execution showing up or being reflected in CPU usage. Let me explain the reason why. It has to do with the way Windows does time accounting. And the way the time accounting happens like this. Periodically, by default, it's every 10 milliseconds, a timer interrupt goes off, and that timer interrupt routine goes and looks and sees which thread is running right now. And then it says, oh, okay, Notepad's thread is running. So I'm going to go ahead and say that Notepad has consumed the last 10 milliseconds of time. And I charge that against its CPU time usage, and I also add that to its cumulative total of CPU time overall. And so when Task Manager or Process Explorer goes and looks at how much time has been consumed in the last 10 milliseconds or the last update interval, it'll see Notepad consume 10 milliseconds for that slice, and if it consumed other ones that built up to some significant number, it will show you a percentage up there in its display. Now, the problem with that implementation is that 10 milliseconds is forever on a modern CPU that's like 4 gigahertz. Tons of stuff can run in that time and not be seen by these clock interrupts that are going off at these long intervals, stuff that runs in between. With Process Explorer, you can add or you can look at what actually ran in between. And the way that it shows you that is through a column called context switches or context switch delta. Let me explain what a context switch is. Whenever the system schedules a thread to run on the CPU, it increments a counter in the thread's control block called the context switch counter. And what Process Explorer does is shows you, for all the threads in a process, the cumulative total of the context switches for all those threads. Now, that alone, just the cumulative total, isn't very interesting. I mean, we can see that if we started a process here at 2 o'clock in the afternoon, and by 5 o'clock, if we've been using that thing a lot, it's going to have lots of context switches. What I'm really interested in is how many context switches take place in that 10 millisecond or that refresh interval that I'm looking at. So if I've got Process Explorer refreshing once a second, how many times have the threads of a particular process actually run? They might not even show up in the CPU usage, but they've actually run. So let's go look on my system now by adding this context switch counter column. So process performance, and here you can see the page that I showed you earlier. What I want to select is context switch delta. And I always add this column. I'm thinking about making it just a default column, but a lot of people wouldn't understand its meaning, so that's why I haven't. But I always, when I run Process Explorer and configure it on my system, add this column. Because look what it'll show you. Let's drag this over so we can see it next to CPU usage. And look at all the context switch, non-zero context switch entries that have corresponding zeros in the CPU usage column. Let me just focus in on one of them. We can see, for instance, this service host is running 21 times a second, because that's what I've got Process Explorer's refresh at, is once a second. It's running 21 times a second, roughly, and yet it's never gets caught running. And so the CPU usage shows up as 0. So what you're seeing here is a lot of cases of processes that are actually doing stuff on your system. They're just not getting detected doing it. They're flying under the radar, so to speak. We're going to come back and look at context switch delta a little bit later. But what I want to talk about now is a problem that a lot of systems administrators face, and even end users face, and that's a situation where you've got a process that's consuming CPU time, and you know the process, but the problem is that process hosts other stuff, hosts more than one thing in it. And the problem you're faced with is what component within that process is actually responsible for the CPU usage that I see reflected in that process. And some common examples are service hosts, which are Win32 service hosting processes that have multiple Win32 services in them, like we saw. iNetInfo in IIS5, which hosts multiple ISAPI DLLs, for instance, including possibly third-party DLLs, which is not uncommon for them to have a bug that causes them to run away with the CPU. But you'll see iNetInfo consuming CPU. The question is what ISAPI DLL of the 20 that I've got installed there is consuming CPU. And the other case is a DLL host which can host external COM objects. So what we need to do to figure out what is consuming CPU in one of these multi-component processes is to drill down to the thread granularity and look at the threads that are running. And we can do that with the thread tab on the process properties. So for example, I'll just show you here for CPU stress. Let's look at its threads. And I'll explain why this delay is here. When this shows up, we're going to see the names of the start addresses of the threads, where they started in the process. CPU stress.exe plus some hexadecimal number. What Process Explorer tried to do while that hourglass was coming up was to go to Microsoft Symbol Server, because I've configured Process Explorer to do that, and it actually will do it automatically for you. I'll let that exercise go to you reading the help file and just following the prompts. But I've configured it to go to Microsoft Symbol Server, and it's trying to look for symbols for CPU stress and to pull them down to show us more accurately the name of the function that those threads started in. And Microsoft hasn't published symbols for CPU stress, which is why I don't see nice function names here. I just see the name of the module that the thread started in with an offset into the module. And you can see that I've got 3 threads running in this CPU stress. One of them is consuming more CPU than the other, and one of them is sitting there perfectly idle. And I've got in the thread column the CPU usage as well as the context switch deltas. If we pull up CPU stress, you'll see that I've got one thread here that's running with low activity and another one that here is running medium activity. And you can guess just by looking at this which one is which. This one's going to be the medium one. So that will show me exactly what's going on there. And if I go into one of these service hosts, like this one that's performing like 34 context switches a second, let me sort by context switch delta. And there are the threads performing context switches. Now, typically what you're going to see if you've got a runaway process, a runaway service host component or a runaway INET info component, is if I'd just done that, at the very top of that list would have shown up the name of a module name and a function name, hopefully, that reveals who's responsible. And I could be able to tie that back to a particular service. For example, let's say that this was, right now I've just got background kind of worker activity going on in the service host, but let's say that it was this thread that was at the very top of the list and consuming my CPU. What is lmh svc.dll? The way that I can determine that is by clicking on this module button right here. And that pulls up the properties dialog for that image. And if I go and look at the description here, it's the TCP/IP NetBIOS Transport Services DLL. And if I go and look at the services that are registered here, well, I can guess that it's that one right there. So that thread belongs to that service. And I would have been able to there pinpoint which service is one consuming my CPU. Now, there's some other situations where we need to actually go a little bit deeper into a thread to understand what its purpose is. And I'm going to show you a screenshot of a real-world example that I encountered what I'm about to show you helped me understand what was going on with a particular process. But the information that we're going to look at is something called a call stack. And a call stack is essentially a record of where a thread has come from to where it's executing right now. Programmers divide up the functionality of their executables or their code into blocks called subroutines, and one subroutine calls another subroutine, and that subroutine might then invoke other subroutines. Well, the stack is the area in memory used to record what subroutine called what, so that when a subroutine finishes, it knows how to get back to whatever called it. So in this case, the stack would show that we might be executing in function 3 right now. The stack would have an address of where we came from in function 2, as well as an address of where we came from in function 1, so that we could originally get back to where we were. Now, the way we can look at the call stacks is just by double-clicking on the thread. So let me pull up CPU stress again. Where'd it go? And look at its threads tab again. after a delay while it checks the symbol server to make sure it still doesn't have it. And I have no control over these delays. This is part of the symbol engine that Process Explorer uses, which is provided by Microsoft. All right, this is taking a while, longer than it. Oh, there we go. So let's just look at what this guy's doing. And it's going to vary depending on what the thread is doing right when we double-click on that. And in this case, this was the stack as it looked when I double-clicked on that. It was in a function called delay execution. Let's click again, see if we get anything again. Delay execution. And that's what I'm likely going to see over and over, because what CPU stress is doing with this thread to have it consume just some amount of CPU is it wakes up, does some processing, and then calls this function delay with some timeout that it'll wake up after and then start consuming a little more CPU. So I'm always catching it sleeping, waiting to wake up and consume some more CPU here. Yeah, here's the real-world example I was talking about. One day, PowerPoint, whenever I would launch it, would take forever to start up. I'd have to wait like a minute or two before it would finally let me look at my PowerPoint. And so I wondered what the heck was going on. I pulled up Process Explorer. I double-clicked on it, went to the Threads tab, and found the only thread at that point in the startup that only had one thread. Clicked on the thread. The start address didn't tell me anything because it just showed me that it started up in PowerPoint's main function. So I clicked on this Stacks button, and I looked, and this is the stack that I saw, which told me that PowerPoint was calling out to a printer DLL, and the printer DLL was probably trying to talk to a network printer that wasn't responding, and it was timing out on it. And the timeout was exceptionally long, which caused PowerPoint to delay in starting up. So that told me, that answered that problem for me right there. Now, another case of time accounting problems has to do with interrupt activity. Interrupt activity relates to hardware devices that are talking to your CPU. And device drivers process interrupts in two ways. One is just by having interrupt handlers respond directly to the interrupts, and another one's with something called deferred procedure calls, where they do back-end kind of low-priority interrupt processing. And those usually go hand in hand, where an interrupt will cause the execution of a DPC, deferred procedure call. One of the big problems with Task Manager, and I've been bitten by this before, is that if you've got a buggy hardware device or a buggy device driver, your machine will start to run sluggishly. And you bring up Task Manager and look at who's consuming CPU, and guess what? Nobody is. It'll say, let's say I've got nothing else going on in the system other than this buggy driver or buggy hardware. It'll say that 99% of my time or 100% of my time is in the idle process. And yet I can feel the effects of something consuming my CPU. And the reason why is, you see that, is that interrupt time and DPC time, Task Manager just throws into the idle process bucket. And it doesn't even show you that is being really used CPU time when it actually is. In Process Explorer, I try to help you understand how your system's responding to interrupts and DPCs by making two artificial processes that show up in the process list. One is called interrupts and one's called DPCs. And here they are in the system. And I have fake descriptions for them here, hardware interrupts and deferred procedure calls. If they were consuming CPU, significant amount of CPU, you would see CPU usage in the CPU column. In fact, they're showing up. Interrupts are showing up right there. If I move around my mouse, I can really fast, really fast. Sometimes I can cause it to generate more interrupts. You also see in the context switch count for this. Now, these aren't real threads. This is just some kind of activity. So what does a context switch count mean for these guys? I've kind of artificially made the context switch count mean the number of interrupts or the number of DPCs that have occurred. So this is telling me that roughly in a second interval, I've got 259, or between 200 and 300 hardware interrupts coming into my system, and I've got roughly 100 to 200 deferred procedure calls executing. So if I've got a problematic driver or hardware device, at least this will tell me that's the case. Now, if I want to figure out which one it is, that's a whole other story that's beyond the scope of this presentation. But at least I've got some idea of what the problem is and who's consuming my CPU. Okay, the next thing I'm going to switch to is talking about the handle view. which we haven't seen yet. It's because I haven't showed it to you. It's a view that you can open and close at will, and it relates to a particular process you've got selected. I've already described what handles are, but just as a refresher, the handles are the open resources of the process at any particular point in time. So I've selected command.exe here, and what I see there is the list of operating system resources that command.exe has currently opened. So it's opened these guys, and it's keeping them open, and it'll eventually close. And when the process exits, all of these handles get closed automatically for the process. So there's no such thing as a handle leak beyond process death. And this can be useful for understanding who's got certain things open. I'm going to show you that in a second, how that's probably affected you, and how you've probably wanted to have the answer to that question on occasion. Process Explorer shows you these two columns by default, the type and the name column. There's two other columns you can select for the handle view. One is called the handle value, and one's called the access mask. The handle value is the handle as seen by the process itself. So this is how it talks to this resource, is through handle number 4C hexadecimal. And the access mask is the permissions it got when it opened that resource. And that's something that's useful typically for developers. Now, by default, it sorts this by the handle type. And you can see that there's some handle types that you recognize, like file and like key. Files for open files, but not only open files, these can represent open devices. And if I clicked on, for instance, Internet Explorer, and I look at the files open, I see the device WMI data device, I see device TCP, these are the TCP endpoints that we saw. So files mean more than just files on disk in the operating system's point of view. Let's go back to the command prompt. Now, these are registry keys. These are synchronization objects, this keyed event, this mutant, and a section is a shared memory section. And Windows stations and desktops have to do with how this thing is interacting with the graphical display. One of the interesting aspects of refresh highlighting is refresh highlighting applies to this part of the display as well and can be useful for you tracking down handle leaks that might be slow. Let me show you refresh highlighting in action. I'm going to pause the output, and I've got this command prompt. This is what I've got focused, what I'm focused on. And notice that this file object right here points to etox TechEd.04US, which is the current directory of this command prompt. If I change the directory and go back and refresh, well, this directory, etox, is marked as a new handle, and this one is marked as a closed handle because command prompt closed one and opened the other when I changed directories. So if I had a handle leak, I would see lots of green, or I would see green with no red showing up. Oops. Now, the other way that the handle view is very useful, I think, is in tracking down who's got this guy open. You've probably run into situations where you go and try to delete a file or directory, and you cannot do it. You get an error. And let's go see what kind of error you get. I'm going to try to delete the PowerPoint presentation that I'm currently showing you. And the error that I get is the process cannot access the file because it is being used by another process. It doesn't tell me what other process is using it. And that's probably the answer or the question that you've wanted to ask and get an answer to on many occasions. How many people have run into that situation before? Okay, I'm going to show you how you can answer that question in 2 seconds. Who's got this guy open? Well, we know, but I'm going to show you how, if we didn't know, we'd be able to figure it out. And that's through the Find Handle dialog box right here. So I open this up, and what I do is type in a partial name of the resource that I'm interested in. In this case, it's something in the etox folder, so I can enter etox, and it would match against that, all handles to resources that have names that have etox in them. But I know that this is a PPT, so I'm just going to enter PPT. I doubt there's any other handles to any PPTs on the system. And I say search. And there it is. PowerPoint.exe, process ID 3972, has an open handle to that PowerPoint. If I click on this, it takes me in the display to that handle. You can see it selected PowerPoint, and it selected that handle down here in the bottom. If I double-click, it'll take me to that handle and dismiss the dialog box. So I've got my answer there. Now, what if we need to be able to delete this file, but we can't because this guy has it open, and we can't kill this process because it's doing something useful for us or something important, and killing it's not an option, but we still need to delete that resource. Process Explorer, I've added something that's, I think, a little dangerous, is this force the handle closed option. And if you read that text, it says, forcing a handle closed can lead to an application crash or system instability. Continue with the close. So let's have a vote. How many people say no? Yeah, you want me to continue with the presentation undisturbed? Okay. Yes. All right, let's go ahead and try it. So yes, and the object just disappeared. Okay, so now what's going to happen when I go back to my slideshow? Let's see. How many people say when I press the next button, PowerPoint's going to crash? How many people say it's going to be just fine, like nothing happened? All right, let's see. So I've got a kind of a mix there. And the answer is it's just fine. Now that's reliability. That's Microsoft Office. Actually, the answer is in the next section on DLLs that I'll tell you how that is actually working and why it didn't crash. So just to summarize some of the ways that you can use the handle view is to solve file lock problems like we just did. Who's got that thing open? To understand the resources used by an application. Sometimes going and looking at the registry keys or files that something has open can help identify its purpose. Because you can see the names, for instance, of registry keys associated with a particular application or files associated with an application. And then you can detect handle leaks. You can detect exactly what types of handles are leaking. In fact, Dave Solomon, my co-author on the book, and who's the guy that's actually suggested a lot of the features that I've talked about, he's used the handle leaking feature. He got a laptop from a Japanese company. Starts with a T. I don't want to embarrass them. And this laptop was eventually, after a few days of running, would run out of virtual memory. And he figured out it was a handle leak. And he figured out it was a handle leak in one of the laptop, keypad or mouse pad applets that ship with the thing. And he used Process Explorer to figure out exactly what handle it was leaking and sent a report into the website, support website, and got back an answer from the developer saying, thanks for pointing out what handle we were leaking. We fixed it, and we've released an update. So the next section focuses on the DLL view. And Dave Solomon doesn't like the fact that I call it the DLL view because he thinks that it's misleading. It's really not just a list of DLLs, as you'll see. It's a list of everything that's been memory mapped, all files that have been memory mapped into a process's address space. It just so happens that executables and DLLs are memory mapped for execution into process address spaces. But applications can memory map other things, data files they can memory map, and that's a simple way of making a file appear as virtual memory. And applications use that for high-speed access to files. Let me go ahead and show you DLL view. And the way that I get to that is by saying View DLLs here, just this button. You see it toggled into a View Handles button. And the default columns I've got in here are the name of the image, the description, the company name, and this is the same kind of information that we saw up in the process view, the same stuff that a developer can put into the image, the version number, and if we've got hover the tooltip over this edge, we can see the full path to the particular image. So the version number is something that can be useful for troubleshooting application problems because you've got an application that's running fine on one system, it doesn't work on another system, you suspect it's a DLL versioning problem, you do a save as right here, and save the display of Process Explorer to a file on the good system and the bad system, and then compare the DLL portion of the output, and of course you've got to sort them both the same, but then you'll be able to see differences in version numbers and be able to highlight which DLLs might be causing you the problem. The other use for this is to identify what's got a particular image mapped into it. What processes have a DLL loaded, for example. And the way that you can determine that is the same way that we found the handle, and that's using the Find DLL dialog right here. Now, you've probably run into this situation, which is you try to delete a file and you get this. Access is denied. Look, I tried to delete the same PowerPoint that I tried to delete before. When I tried to delete it before, I got the process cannot access the file because it is being used by another process. This time I got access denied. What's changed is that I closed the handle. So when the handle's closed, I get the notification about somebody else using this thing. But when there's no handles open to this, and it's still being used by something, I get this access denied message. So I go and look at the security properties for that file, and I go look at the directory, and I see that I've got full permissions to delete this. So what's going on? Somebody else has this in use. Who's got it in use? Let's go back to Process Explorer and do a search. And there it is. Double click, and here I am. This is it mapped into Process Explorer's address space down here. And that is the answer to why PowerPoint didn't crash when I closed the handle and I did a next. It's because it's mapped the PowerPoint into its address space, so it really didn't need the handle to access the data that I'm showing you. It's just pulling it out of virtual memory because it's being backed by that file on disk. So the last thing I'm going to show you, the last feature, is the system information dialog. So I had this lacking in Process Explorer for a long time, and that's the view like you see in Task Manager here in the Performance tab. And people would say, well, you know what, I like Process Explorer, but I'm always going to have Task Manager around because I rely on this CPU history and the statistics down here to keep track of things. So I've added this system information dialog, which you can access through this menu or just by typing Control-I. And you get something that looks a lot like Task Manager, except it shows you more information. So, for example, Task Manager will show you the current virtual memory commit charge and the limit on virtual memory, the total maximum size of virtual memory on the system. But it shows you them as numbers, and I thought it would be more intuitive to see them as percentages so I can see just how close I am to my limit. So the peak virtual memory usage on this system has been 10% of the maximum, and the current rate is about 8.8%. I also see physical memory statistics like in Task Manager. And down here in kernel memory, Task Manager shows you some kernel memory statistics, but it's showing you, it's missing a key piece of information if you look at this data over here. It shows you the total amount of paged memory allocated on the system and non-paged. If these paged memory and non-paged memory come out of limited pools of buffers in the kernel, if either the paged pool or the non-paged pool become exhausted, you're going to start having system failures. You're either going to have applications that don't function properly and tell you that there's insufficient resources, or if you've got a driver that doesn't check to see if it got back pool, and pool was out and it got back a null pointer, you're going to get a blue screen. So the reason why this is important is so that you can have some idea of, do I have a pool leaker on my system? How close am I to my limit? If I've got insufficient resource messages, is it because I'm out of pool or near being out of pool? The key piece of information you're missing here in Task Manager is, what's the limit? I mean, I don't know how close I am to the limit there. I could be really close or I could be really far away. So what I've done in Process Explorer is shown you the limits. So the page limit on this machine is 364 meg. Right now, I'm at roughly 35 meg. The non-page limit, 262 meg, and right now I'm at 11 meg. And then these areas over here, those aren't shown in Task Manager. These are statistics, system-wide statistics on paging as well as CPU and I/O. So this is the context-switch delta per second on the system, and the I/O reads and writes per second. Actually, I've got it in paused mode, so let me unfreeze this so it looks a little more interesting. Now, I've also gone a little bit further up in the top. Remember when I showed you the performance history for a particular process, I showed you that you could move the mouse over and see what time something happened. You get that same ability here, but I show you something else. I show you the #1 consumer of CPU resource at that particular point in time. So you can see I've got I'm moving the mouse, and it's CPU stress, as you'd expect. Now I've got some spikes here. It's still CPU stress in there. Oh, wait, I thought there's PowerPoint. And what I've done is press the mouse button, and I've frozen that tooltip up there on the left. So that spike right there is PowerPoint. PowerPoint spiked at 42% of the CPU. And it did it at 11:41, roughly 15 minutes ago. And I've got the same thing down here, although I don't show you the top consumer of memory usage, I just show you the timestamps. So once you get Process Explorer back, you go back to your office and you download it. There's a number of ways you can customize it for your own use, and you've already seen some of those, like adding the columns, changing the refresh highlighting. Let me show you some other ones. Here in the options, always on top, just like in Task Manager. Hide when minimized. What this does, you see that this is the little Process Explorer tray icon, just like for Task Manager. When I hide when minimized, Process Explorer goes down to the tray. If I right-click, I can open just the system information or open Process Explorer itself. And when I close it, if I've got that option selected, it still stays in the tray. The only way to exit at that point is to go to the File Exit command. Some other options allow only one instance. So this is what Task Manager does, basically, which is the reason why when you run Task Manager more than you try to run it again, you type Control-Shift-Escape, or you run Task Manager, right-click on the system tray, you'll only see that one. It'll come into the foreground. Well, with Process Explorer, I wanted you to have the ability to run more than one, or to have it mimic Task Manager, so that option is for that. And this one I got a lot of requests for, Confirm Kill. This lets you kill processes without being asked, just by typing the delete button or by typing kill process. And without getting a prompt, which I would have gotten a prompt if I didn't have that checked. You can configure the colors if you're not happy with the pretty baby blue and the nice baby pink colors that I've chosen. I won't be offended. You can go and change them in here. Now, finally, well, actually, let me show you one more thing. And I got this at the request of that same guy that on the Microsoft.NET CLR team, Jeff Richter is his name. He requested this, opacity, because what he likes to do is put Process Explorer at 60%, and then he can see Process Explorer at the same time he can see the stuff running behind it. And he figured out that 60% was the ideal opacity level for operating this way. And as your ultimate endorsement of Process Explorer, replace Task Manager. So, just to summarize, Process Explorer, some of the things that I have hoped that you're going to walk away with is how to understand CPU usage on your systems better than with Task Manager, how to be able to identify images, how to be able to find handle leaks, how to be able to find who has a handle open to a particular resource or who has it mapped, how to look at your CPU history and figure out what was doing something on your system at a particular point in time very easily, and looking at the memory statistics that you don't see in Task Manager, like the kernel pool and the page pool and the non-page pool. And I want to just close by showing you one thing, and that's, I don't think I showed you this at the beginning. That's something that I'm quite proud of, and it'll come up here in a second, and that is a knowledge base article at Microsoft. It's the only knowledge base article that is about a Sysinternals tool at Microsoft.com. This is an actual knowledge base article I'm showing you right now. So Microsoft is now supporting my tools for me, which I think is kind of cool. And this, by the way, this knowledge base article has to do with an older version of Process Explorer that didn't work right on Server 2003, right when Server 2003 came up. So this directs people to go to Sysinternals to get the latest version. So with that, I want to thank you for coming. I hope you're going to walk away and start using Process Explorer. And please fill out your evals. Please remember to fill out your evals. I'll be up here to answer any questions. Since it's lunchtime, we can hang out here for a little bit.